would, with me, maybe Simon, you could introduce yourself.
Hi, I'm Simon. I'm a spacecraft operations engineer on the Mars Express flight control team. So I'm one of the people whose day job it is to actually operate the spacecraft and ensure it's working correctly and taking all of the great science observations that it's been doing over the years. I'm also particularly responsible for the VMC camera as well, so we've been sort of heavily involved in that over the years. As Rosa was saying, I mean, it has been nicknamed the Mars webcam for a reason. It's very much the type of camera that you would have walked into your local, I guess, PC World if you were in the UK, or Saturn if you're in Germany. I don't know, maybe Jorge could tell me what the equivalent is in Spain, but in the early 2000s, and because it was there for one reason and one reason only. It was there to take images of the Beagle 2 lander that Mars Express carried to Mars, specifically such that we could see that it was deployed correctly. And in principle, once those images were taken, it was going to be turned off, and there was no plan to turn it back on again. The flight control team, a few years later, decided to have an attempt at recommissioning it, or at least seeing if it still worked. And I think to everyone's surprise, it did. And so for quite a few years now, we've been using it to take shots of the red planet from typically from high altitude, and placing them on social media and on Twitter.
And I just want to say we're 2 minutes away now from the first picture, and in case you're wondering, the graphic that you're seeing moving across the screen many times is what we expect to see over the full hour. So as each picture comes in, Mars will move from the top right of the screen to the bottom left of the screen. So the first image you will see will only have a tiny little bit of Mars in the top right-hand corner, and because it's the first image, it will be extremely overexposed. So the quality will get better after the second picture. And I'll pass over to Jorge, who is a true expert when it comes to the Mars webcam, and he could introduce himself and a little bit more about what's happening, and expect the first image in about a minute.
Hi, good evening. My name is Jorge Hernández Bernal. I am one of the people in the science team of VMC. It's in the last 5 years, more or less, we have been working to make from VMC not just an engineering instrument, but we have been recommissioning it to be a science camera with a lot of work in engineering and in science as well. I am one of the persons who have been working on the science of the instrument, and I am also one of the persons who operate the visual monitoring camera in the day-to-day, and also one of the persons who work on the data processing of the camera to make it available to the world. And in the last, we are very close to have the first image. Actually, we have been working a lot in the last few months to make a specific software, because we usually we don't retrieve science data in real time. So we needed really to change our operational software to make sure that we are able to retrieve the data in real time as it reaches to the ground antennas.
Oh, it looks like we might have something. And just to remind you, for anyone who's just joined now, this is the first ever live stream from Mars, and it's coming from the Mars Express spacecraft. That is an ESA mission, 20 years old today, so wish Mars Express a happy birthday. And it, about 16 minutes ago, sent its first image down to Earth, and the teams here have been working very hard to make it possible that you can see that as soon as humanly possible. It's coming, everyone's quite excited. As we said, the first image will be quite overexposed, and Simon and Jorge can explain a bit why that is. And the images after that should be a bit more detailed. As we've said before, this is Ooh, ooh. Here it is. This is the first image from Mars, and it's the most live you'll ever get, unless you travel to Mars, to the red planet itself. This is Mars 16 minutes ago, and Simon, maybe you can explain why we can't see what's happening right this very moment.
Well, it's actually very simple. Mars is a very long way away. As we can see on the actual stream at the moment, over 300 million kilometers. The images are traveling effectively from Mars Express to the ground station in Cebreros in Spain right now. And even though they're traveling at the speed of light, that distance is so huge. It takes 16 minutes and 44 seconds right now for those images to travel from the spacecraft back to Earth. So what you're effectively seeing right now is essentially, if you were currently sitting on board Mars Express and effectively sort of looking to your left, then this is what you would be seeing. We typically don't normally get images in this way. The way in which Mars Express captures most of its science is what we would call store and forward. So basically, it will look at a part of the red planet. It will take pictures or use its spectrometers or its subsurface radar to collect the data. That data is then stored on board the spacecraft, and at the next opportunity that we have to talk to the Earth, because on Mars Express, the actual antenna system is attached to the spacecraft. It doesn't actually move. So we have to slew the spacecraft to look at the red planet and then slew it back to point the antenna at the Earth. And so the next opportunity that we have, we transmit the data back. So, the scientists could typically be waiting, a couple of days potentially for some of their observations. Today we have a very unique sort of opportunity where we've got an ability to have a very specific pointing. So the spacecraft is not in its normal Earth pointing mode right now. It's sort of slightly rotated towards the planet, because that then allows us to enable VMC to see Mars whilst we can keep the antenna pointed at the Earth. And in fact, actually, the reason the stream is actually only about an hour long is because we can only really maintain this pointing for about an hour because of the way in which we have to orientate the solar arrays, and so it will start to put a load on the spacecraft's batteries if we were to stay like this for too long. This is certainly the first time that we've ever actually been getting real science data back in real time. It's quite a rare occurrence for deep space missions.
And for anyone who's just joined, a quick reminder that this is Mars Live, and this is for Mars Express's 20th birthday from ESA, the European Space Agency, and we're looking at, I think this is still the first image, or possibly we're getting the second image in.
No, this is the number 5.
Ah, we've had 5 images. Okay. Oh, you can actually see it move a little bit. That is cool. It will get more, you'll see more of Mars soon. Maybe, Jorge, you can also say why we're only seeing a little bit of Mars at the moment.
Yeah, actually, as Simon was commenting, right now Mars Express is a very specific pointing, because the antenna is pointing to the Earth and VMC is pointing to Mars. And because of that, we are going to see how Mars is moving from the top right corner to the bottom left corner. And now it's still in the corner. We can see that in the top part of the image, it's the night. It's much darker because it's the night there. Actually, in the bottom, in the right side of the image, we have created this three-dimensional graph. So in the position of Mars Express and the planet, and we can see in this graph the night, the day, and also we can see a curve on the planet that represents the part of the planet that we are seeing. We are seeing the southern hemisphere of the planet. And actually, it's very funny because we are seeing a cloud next to Martian Mons right now. It's kind of hard to see that in the left side of the image, there is kind of a white thing that corresponds to a cloud in Martian Mons. This is not the famous Martian Mons elongated cloud, which, as many people know, those who follow VMC, that's a cloud that we found some years ago that expands up to almost 2,000 kilometers. In this case, this is not that very special cloud, but this is a different cloud. This is an orographic cloud in Arciamons. We are right now in Mars. We are approaching we are in the aphelion season, which is more or less the cold season. We are also approaching the northern summer solstice. So actually, in Mars is right now kind of a similar time of as in the year. And in Mars, because we are in the aphelion, we are in the colder season, and this is not the dusty season, not that season in which we have the dust storms, but this is the season in which we usually see a lot of clouds, mostly in tropical latitudes. Well, we are lucky because we don't always see so clearly a cloud with VMC, and in this case, Arciamons is very close to the border of the planet, and there is an orographic cloud there. There are other features in the image. Actually, as I told, this image is showing basically in southern hemisphere of the planet, and we don't see the south polar cap because the south polar cap is now covered by the night. But around the area, usually in this season, we can find a lot of hazes. Just they are very hazy and they are not so clear. But I think that I can see that it's a bit cloudy in the southern hemisphere.
So I see we're getting a few questions in at the moment. So one of them was actually how much time does it take Max to actually make a full orbit of the planet? And it's actually just over 7 hours. So we typically do about just over 3 orbits a day. And actually, as Jorge was mentioning, you can see part of the planet is actually in darkness because it's nighttime on the back side of the planet. And actually, what you will notice is that as the planet is moving effectively from the right to the left of the screen, so we're actually heading into the darkness, and that's actually a particular effect that happens throughout the Martian year. So Mars Express's orbit periodically takes it in a position where the planet is between the spacecraft and the sun. So that's actually where we're heading right now. So in a few hours' time, the spacecraft will be behind the planet with the reflected sun and effectively in darkness. And so at that point, its solar arrays are no longer generating any power, and it's completely reliant on its batteries to stay alive. And so this is a particular, the eclipse seasons that we have an impact on the operations of the spacecraft. And on the science as well, because obviously, whilst we're eclipsed by Mars, we're completely reliant on the batteries for power. So we have to dial down the amount of power that we're consuming so that we don't hit the batteries too hard. So we have to turn off some of the science instruments, or we can't run them for as long, or we have to take measures to to keep the spacecraft warm, because obviously not only once it goes behind Mars and it's no longer in sunlight, not only do we lose power, the spacecraft is also getting very cold. So we take steps to try to reduce the overall power consumption by doing things such as, once this stream finishes, a lot of the heaters on board Mars Express will then switch on and go on to full power to try to basically warm the spacecraft up as much as they can, such that when we approach the eclipse entry point and then we lose power from the arrays, those heaters will then go off. The spacecraft will cool down, but it will be cooling down from a much higher temperature, so that the heaters don't need to come on whilst we're in eclipse and we don't have power from the arrays. And so when we come back out the other side, the spacecraft will be cold, the heaters will come back on, it will warm up, but we won't be using the batteries to run the heaters. And that's, in a spacecraft that's this old, I think, our batteries are lithium-ion batteries, so it's very similar to the sort of things you'd have in your mobile phone. And I think everybody's got used to now the fact that after a number of years, your mobile phone charges very quickly, and it also runs out of battery very quickly. And so, lithium-ion batteries do age over time. And so when, on a mobile phone, you can either go and get a new battery, or you go and get a new phone. On a spacecraft, it doesn't quite work like that. So we have to do everything we can to look after them. And so, we've been doing these various measures to ensure that, we don't discharge them too much, and that we keep them topped up at most of the time. And so we found, basically by running them, by keeping them colder and not discharging them more than about 40%, that they've actually survived much, much longer than we ever thought they would. And in fact, actually, even some of the battery experts who've analysed our telemetry are quite amazed at actually how well they've held up. So I think the takeaway from that is that if you really want your mobile phone battery to last a long time, then don't discharge it more than 40% and keep it in the fridge at all times.
You heard it here first. We're actually about to be joined by one of the Mars scientists that works at ESA, so we can tell you a bit more about what's happening at Mars. Has there ever been life on Mars? Could there ever be life on Mars or water? But for anyone who's just joining, again, this is the first ever live stream coming direct from Mars. It's taking about 16 minutes for light signals to get to us. And we're getting this footage from ESA's Mars Express mission, whose birthday is today. And it's coming from the visual monitoring camera on board Mars Express. And actually, we have Colin here, who perhaps can introduce himself and maybe could talk about some of the other cameras on board Mars Express, as well as this one, and your personal connection, I think, to the VMC and its views.
Great. Hello. Yes, my name's Colin Wilson. We are here celebrating the 20th anniversary of the launch of Mars Express. So 20 years ago today it was launched. In fact, the exact anniversary will be in 1 hour 45 from now. So we're preparing a toast for that occasion. It's special for me because I did my PhD. I built a bit of equipment which went up on the Mars Express rockets. It was part of the weather station on the Beagle 2 lander, which went up with Mars Express. So that launched on the 2nd of June. It then arrived at Mars in December, on Christmas Day, 25th of December, 2003. Unfortunately, it was not successful in landing and then communicating back to the Earth. But we all knew it was a high-risk mission, but it was certainly a very emotional time for us all watching and waiting to see whether that survived. But that was Beagle 2, the lander, and of course Mars Express, the orbiter, has had a tremendously successful 2 decades of exploration of Mars. But I don't want to just talk about myself. What are all the questions which people have been sending in about this stream?
Well, some people are asking about life on Mars, water on Mars, and we had a specific question about one of the clouds on Mars. What's it made of and what is it? And I think this is in relation to what Jorge was telling us earlier about the huge elongated cloud that looked a bit like a volcano was erupting, but I think it wasn't.
So I think really the experts about the clouds, especially around the volcanoes, are the science team behind this VMC, this camera, of which Jorge is probably really the leading expert. So I'll hand back to him in a minute. But in general, if you want to ask about water on Mars, really the Mars Express spacecraft was put together to investigate water in all its forms. So from subsurface water and ices, looking for that. And Mars Express, one of its first results was demonstrating that there is indeed water ice in the polar caps of Mars. And not only can it see there's water ice in the polar caps of Mars, but it detected strong radar echoes from the subsurface, and then strong radar echoes from the base of the polar cap, which suggests there might be liquid water underneath those polar caps. Now, this is still controversial. The interpretation is not simple. It might be liquid water mixed with ice, a bit like a slush, but that's certainly very exciting. But so Mars Express has been investigating water there. It's been investigating the history of water on the surface, so these valleys carved by rushing water torrents, rocks which must have formed in the presence of water, so hydrated minerals and clays. And then up in the atmosphere, the atmospheric water cycles, the clouds as demonstrated, and then even the escape of water to space. So the questions are, what are light spots and white spots? And really for this, I have to turn back to Jorge, who's the expert in these clouds.
Well, actually, just a couple of minutes ago, as Mars is moving our field of view, a new clear cloud has appeared. This is a cloud that it actually looks like a bright spot in the right field of the image right now. And actually, this is a high altitude cloud. Probably this cloud is something around 50 or 60 kilometers over the surface, and it's projecting a shadow. If you look carefully to the image, you can see right on the top right side of this bright spot, which is a high altitude cloud. There is a dark feature, and this is the shadow of the cloud. Here it's the morning. We are very close to the southern pole, so actually this is kind of this is like on the year when you are in very high latitudes. You can have days around the southern around the solstices, in which the sun doesn't set or the sun never rises. And here we are in a similar region. We are very close to the polar night, and close to this part, it's right now it's the morning, and there is where we see this cloud. Actually, with VMC, we have been working a lot on high altitude clouds in the twilights, right? Like in the morning, in the very early morning, and also in the afternoon, right after the sunset. And well, this is an amazing example of this kind of cloud, and I'm very happy that we are seeing so many interesting features in this image, mostly because they are features that they are kind of easy to appreciate. Apart from that, they were asking about the points, the other points, the other features in the image. Also, close to the night, a bit on the top of the feature, of the bright feature that I told that is a cloud, there is a white area, more or less. It looks a bit like if it was a milky area, and that's the polar cap. And in the border of the polar cap, there is something like there is a bit more darker, a bit more brighter in some parts. That's one of the craters. I will need to check which one is this, but this is one of the craters. The southern hemisphere of Mars is covered by a full of craters. And well, there are other things in the image. Basically, there are a lot of features because a lot of topographic features in specific, and there are also some hazes around. But like we have basically two very clear clouds, which are very opaque clouds, and they are very bright. And then we have a lot of topographic features and a lot of hazes that are around, but they are not so easy to spot.
One of the questions we've had a lot is about why we can't see any stars, and also if we could possibly see Mars's moons. So over to Colin.
Okay, so the question about stars is completely fair. The answer is simply that Mars is very, very bright. So you can see Mars from the Earth. You can see the planets appear. If you look in the evening sky tonight when the sun sets, the first thing you'll see, as the sky gets darker, the first thing you'll see, other than perhaps trees and planes and things, is Venus. Venus is a very bright planet, but then to the left of Venus, you will also see Mars. It's bright, and it's bright here from Earth. But if you're very close to it, it is even brighter. And so it's so much brighter than the background stars that that's why they do not appear in this image. But if you were in space where this camera is, you would be able to see stars when you turn away from Mars. And that is, in fact, critical to how Mars Express navigates. And many of our spacecraft navigate by having star cameras, and they have on board, they have star maps, and so they, like mariners of old, they navigate using the stars, and that's how they know which way they're facing. So if you were where the spacecraft is, then you would see stars. There was another question about how we know these are clouds. So here's Jorge again to tell us.
No, but first I wanted to comment on the stars, because with EMC, actually, for calibrations, we have sometimes spotted both Phobos and both the stars, but for that we use very high exposures, and we point to a very different position where Mars is not present. Otherwise, Mars will be so bright that we will not be able to see anything.
So we often can see the moons of Mars from Mars Express. Mars Express, as you can see on the right hand of your image, it's got quite an elliptical orbit. So the big ellipse you see shows how far from Mars sometimes the Mars Express gets. And right now this ellipse shows it's got an epicenter. It's furthest from Mars when it's high over the southern hemisphere, but that does vary. So sometimes we're high over the equatorial latitudes, and when that happens, we pass really close to Phobos, which is the bigger moon of Mars. So sometimes we pass as close as 50 kilometers from Phobos, which is very, very close. And so then we get very good images indeed. And so Mars Express has been critical for building up images of that moon. So this is quite exciting because coming up in a few years, we've got a very ambitious mission, which is the Japanese-led Mars Moon Exploration mission. So ESA has a small part of that. And we will be collaborating with them. But that is not only going to image the moons in detail, it's going to orbit Phobos, and then it's going to land on Phobos briefly. It's going to touch down on the surface, grab a sample of the moon, and take off again. And then bring that sample, which is grabbed from the surface, it's going to bring that back to Earth. And that's very exciting. So apparently there's questions about the rotating graphic on the right. Jorge, do you want to say something about that?
Well, I don't know what are the questions.
Yes, I think some people would like to know about this graphic on the bottom right that we've been showing, and that was one that you made. Maybe you can explain a bit about it.
Yes, basically, as part of the LEAP observation, we wanted to allow people to really understand a bit what we are seeing. So when we made this graph, in a way that we can see that Mars Express is, as Colin was telling, in the epicenter of the orbit or close to the epicenter. And in this graph, basically, we see the planet, and for the map of the planet, we choose a topographic map of the planet, because this way we can really see what are the features, the topographic features that we have there. And well, indeed. The part of the planet that we can see in the image is the one, basically there is a circle that is around Mars, and then there are two lines that go from the border of Mars to Mars Express. Those lines are showing us which are the limits of the part of Mars that we can see. And then the circle that is around Mars, it is also allowing us to see which are the part of the planet that we can see. And what we see is the southern hemisphere. And well, basically, we wanted to make this kind of graph to try to help in an understanding of what are we seeing here, which is basically the southern hemisphere. But for example, now in a moment, okay, now we have seen the Tarsis Vulcanus in our site. Let's wait a bit for another rotation. Like there it is. There it is, Tarsis Vulcanus. So we see that the limit of the part that we can see is in the volcano of the middle, and we can see the volcano of the south. The volcano of the south is Arsia Mons, and we can see in the three-dimensional graph that this is part of the area that we can see, and indeed in the leaf image we can see this volcano like a brown spot, a dark spot in the left part of the image, and then as I told before, we have right now a small cloud right in the bottom of this volcano. This cloud is growing to the west, which is kind of the common thing in the season. In the season in Mars, we see a lot of orographic clouds in the volcanoes of Tarsis, and here we have a very good example. But well, basically,
okay. Stop talking about the clouds. We've got drama. We've got high drama here, because you may be noticing that the image is not changing. And so this image was acquired at 1805, and then if you add this travel light time, this image will have reached Earth at 21 minutes past the hour. But that is some time ago. So what has happened? We're just hearing from the people in the spacecraft wizards who are driving it. There is apparently bad weather around the receiving station, which is corrupting the reception of the signal. So this is where I would like to hear more about exactly which is going on. Which ground station are we using for the reception of this signal?
Cebreros.
So we're using the Cerbero station, which is near Madrid. It's just west of Madrid. My colleagues in Madrid, because we have Science Operations Center for Mars Express in Madrid, tell me that after months of dry weather, it's been raining in Cerberos. And so apparently bad weather at Cerberos is corrupting the signal. So we did have images coming through 10 minutes ago, 20 minutes ago. So we can hope that there are some more images will be released soon. So what's the latest on that?
I would just say, if people are interested, the ESA's S-Track ground station network has 3 very beautiful 35-meter antennas, and you can go onto the website. You can, if you're missing a live view because ours has currently frozen, you can actually get a live view of the deep space antennas, and you'll see in Spain some miserable clouds over our antenna. And breaking news that telemetry is actually back. So we might have to wait a bit to get the next image. But keep your questions coming in. Again, this is the first ever Mars Live. It's coming to you from Mars Express, ESA's 20-year-old mission orbiting the red planet. Colin.
So what we've just heard is we are now receiving signal again at the station. So you may be thinking, why are we not yet seeing an image? So this is now not the light time from Mars we're waiting for. We are now waiting for the reception, the latency between computer systems on Earth. But it is apparently working, and we're expecting the next signal to pop up on your screen anytime now. But it just does illustrate that we are using the spacecraft in a different way than we're normally used to.
Maybe Simon, maybe you could.
Do you want to say something about
we have Simon, who's been running around trying to figure out what's happening, and lots of people are asking about this in the chat. Simon, what's happened, and when can we expect the next live image?
Okay. So what we actually believe is going on at the moment is actually down to the weather. Unfortunately, alas, not the weather on Mars, but the weather in Spain is causing some intermittent problems with receiving the signal. This is not completely out of the ordinary. This does happen from time to time, and it's part of the daily life of operating spacecraft in and around the solar system. Right now, we have actually, as I say, we're starting to receive telemetry again. It is a little bit intermittent, so hopefully we will be able to get a few more images in, because there are effectively 2 different data streams coming from the spacecraft. There is effectively what we call the telemetry stream, so that's telling us what the spacecraft is doing, things like its temperatures, its battery voltages, what its reaction wheels are doing, where it's pointing, its various modes. And then there's a second stream, which is the science data. And so, as we say, it is a little bit intermittent at the moment. Hopefully we will be able to get some complete images in. We'll just sort of have to wait and see.
So in the meantime, we can try to answer some more questions online. So lots of great questions in there. One is from Ramona Virus. Why does the orbiter have an elliptical orbit and not a circular orbit? Is this on purpose? This is on purpose. There are many reasons for which you might want a low circular orbit, like if you have a radar orbiter or a camera, it's always useful to be close to the surface. But the thing is, it takes a lot more fuel to get into a low circular orbit. When you're arriving from deep space, you can imagine as you approach the planet, you accelerate as you get pulled in by its gravity, and you get closer and closer. And you have to make sure that you're not going to hit the planet, that you swing by it. So you accelerate as you get closer to the planet, and you swing by and you decelerate as you go off into space. So what happens at that point, if you want to go into orbit, is you have to use your rockets or some other way of decelerating and go slower and slower. And so what Mars Express did, for example, is it used its main rocket engine to slow down. And at that point, it then gets captured by the Martian gravity well, as you will, and then it enters this highly elliptical orbit as we have it here. And that is where Mars Express is, and that's why it's in an elliptical orbit. To go to a low circular orbit would have taken a lot more fuel. Simon Wood again, spacecraft operations wizard.
Well, actually, I mean, the elliptical orbit's also there really for part of the science mission as well, because what the original kind of concept or the idea was that you would do your science when you're very close to the planet, and then you would have the period when you're further away to be able to communicate with the Earth. But actually, the orbit that Mars Express is in has been very, very carefully designed, because orbits aren't inherently, they're not static. They do move around, and so what you see is that Mars Express's orbit rotates throughout the Martian year, both what we would call sort of in plane, so basically sort of the point at which is closest to the planet constantly changes, and also it rotates sort of effectively with the planet as well. So you have a situation whereby the longitude and latitude of your closest approach is constantly changing, because both the planet's rotating underneath you as you're orbiting it 3 times a day, and also because the plane of the orbit is turning, you're constantly getting different latitudes as well, which allows you to get this global coverage over the whole planet.
And that's a point, we get this on Earth as well. Some satellites operate close to Earth, some satellites operate far from Earth. And when you have satellites far from Earth are great, for example, for weather maps, whereas satellites close to Earth are better for comms, communications, and spy satellites and things where you want high-resolution imagery. And so this orbit from Mars Express really does both. It gives you the faraway, distant views, and as well as the close-up views. And when it's far from the planet, it can do things like fly close by Phobos, which is quite far from the planet. And it can also study the ionosphere and the solar-wind interaction. So sometimes it's far outside the bow shock, the ionosphere, and sometimes it's inside, so it can study that whole solar-wind interaction. Great. Have we got further questions, or do you want to say something else?
We have absolutely loads of questions. Some people have asked again, how often are we taking pictures? And it's roughly every 48 seconds that a new picture is taken, and it's roughly 16 minutes and 44 seconds for the light signal to get to Earth from Mars, and then a bit of time on Earth due to wiring and signals and things on Earth, but also the weather has been getting in the way a little bit of our live stream. But we're expecting a new image anytime now. But we've actually been joined by a new guest, Daniela, who's working at DLR. And maybe, Daniela, you could introduce yourself and say a bit about Mars Express and your special camera that you have.
Yes, hello everybody. This is Daniela. I'm working at the German Air Space Center in Berlin. I'm part of the HRSC camera team, so the stereo camera on board of Mars Express. I'm doing observation planning. I'm happy to do this. It makes a lot of fun. So I can decide which images we observe from Mars, for which purposes. And I'm struggling with ESA and all the other instruments to get those images down. And I know Mars very well. I'm working on this mission since 2005. It's almost the entire 20 years now. And I became part of this dear Mars family.
We had a question from Jacqueline Rosales, who's invited young students to watch. So hello to all of her students and any other students who are watching. And she said that she'd like a really kid-friendly understanding of how signals are plucked out of the air and translated into visual and readable data. And I think that's a good one, not just for kids, but I'd quite like it myself too. Jorge, maybe you could take this. How are signals taken from the air and translated into these images that we can see visually?
Yes, that's a long process, because what we get from Mars is basically a bunch of ones and zeros. So there are a lot of interfaces in the middle, because I, as a scientist who works in data processing, basically get some data from the engineers, but the engineers have they have other systems and they see a lot of other things, and they filter. Whoa, we have a corrupted image. This is because
art.
Yeah, this is a bit like art. The thing is that because we have this bad weather, well, the program that we have here processing, well, now we are receiving, I think, yeah, I think that it's going to solve in a few seconds probably, but basically what we have here is that because we have bad weather, we load some packets, I will speak about this in a moment, and because of that, the program was not able to solve the real image, and it basically puts, here we have a good one. Yeah. I think that it's going better. Actually, Simon was telling me that the weather is going better. Basically, in the case of PMC, we have 76 packets. These packets are the kind of the way in which engineers put the information in a way that the scientists can really access to the data. And yeah, with these 76 packets, each packet includes more or less like 4 kilobytes of information, and from that, basically, each byte corresponds in the case of BMC to a pixel of the image, and then we create the BMC image from those packets. Now, because in the case of BMC, it was not designed to be a science camera, so there is a lot of processing to be able to obtain beautiful images like this, and this involves a lot of things. One of the things is the thing of the color. It's very common to ask what is the real color of Mars, and in fact, in these images, they don't show the same colors as we would see with our eyes. Actually, color is a very complex topic related to the way in our eyes work. But basically, in the case of BMC, the color is more or less with the same system as with mobile phones. They have something called Bayer pattern, which is that each pixel has different colors, and then we make color images from that. But it's not like it's not the ideal science color image. And well, we also remove the noise, and we do different kind of processing to try to obtain an image that looks like this. From the ones and zeros that we get from Mars, and that engineers process a bit for us to help with that, because they really get actually away from the antenna that I will not understand, and they help us with that, of course.
But actually, I mean, for Daniela, I mean, it's even more complicated with your camera, because you don't just have a flat image; you actually take pictures in 3D.
Yeah, we do not take them in 3D. We take them in 9 different channels, 4 color channels and 5 panchromatic channels. And we use basically 4 of those 5 panchromatic channels, which are taken at different viewing angles to produce a digital elevation model. The principle is just as how we do this with our eyes. So we have 2 eyes of 2 different positions, and we look at the world with 2 different viewing angles, and our brain creates a 3-dimensional image of this. And we do pretty much the same, just a little more sophisticated. And so we get our 3-dimensional images. So, but this is a long way of image processing, and the raw images are, of course, they look like a photograph. But very long photograph. We don't take our images like a framing camera. So at one shot, you get the entire area. What we do is we have a scanner, a line scanner. We scan the surface in thousands of lines and stitch them together in a very long image stripe, which we also call an orbit.
Okay. The questions are coming in very fast, and I think we're taking a long time to answer these questions. So we can try giving some short answers to questions. There's some fascinating questions in there. One question I just saw is, what is the power broadcast from the spacecraft, and what is the power received at Earth? Simon, have you got? I think it's tens of watts at the spacecraft.
I think the transmitter on the spacecraft uses 120 watts of power.
And then it transmits about like 5 or 10 watts of transmitted power. So if you imagine a 10-watt light bulb or something like this, that is about how much power we are sending from Mars. So it's phenomenal to think that you can observe something consuming as much energy as a light bulb from 300 million kilometers away. So that's how much is broadcast, and then by the time it's 300 million kilometers away, we are sensitive. I think I saw a plot today of zetawatts, which is a millionth of a millionth of a thousandth of a watt. It's a tiny amount, and that's just a testament to how sensitive the receivers are in these very big dishes. So that's the power question. Just jumping randomly between these questions, there was a question about the cost of the mission. So this is something we get quite a lot. Mars Express was built for, I think the project cost was 150 million euros. In fact, that's not correct because it's 150 million écus, the European currency unit, which is a precursor of a euro. Again, a reminder of how long ago it was that this was agreed and built. So if you just think the number 150 million sounds like a lot, but that is like 50 euro cents per person in Europe. So what can you buy for 50 euro cents? You may be thinking of a candy bar, and now you can think also of a Mars spacecraft. So if everyone contributes 50 euro cents, you can buy a Mars spacecraft.
I have a question that's kind of related to the value, but why does it matter that we understand about Mars? We had some questions asking about if we're talking about Mars weather or Earth weather that's getting in the way of the signals, but how does Mars help us on Earth? Does it help us, or is it just kind of escapism, interesting? What's the point?
So there are lots of different there are lots of different answers to this question, and different answers work for different people. Some people like to explore Mars because it's there. It's like the answer about Everest. It's the human spirit to wonder what is on the frontiers, what is out there, what is next door. Some people think of Mars as a future place to live or explore. I think in the short term, don't sell your house because it's not. It's very difficult. We can't breathe there. But the European Space Agency, like many space agencies, does intend to send people there on exploratory missions. If you are not moved at all by the exploratory instinct of Mars, you can also think that a lot of space exploration is useful for Earth. We have weather satellites observing Earth. We have communication satellites. We have GPS steering our vehicles. And the money spent on planetary exploration is at least an order of magnitude, at least 10 times less than what is spent on Earth orbiting satellites, which are used in our daily lives. And the planetary exploration does help develop technologies which are for our benefit on Earth. Daniela, did you want to add something?
Yeah, there's one neat thing about Mars I wanna add to the list of reasons why we do this all. The thing is that Mars and Earth are almost the same age, and they experience the same conditions in our solar system at the same time. But on Earth, everything, all the surfaces are relatively young because we have plate tectonics that eat the surface and renew it again. We have a lot of weather and erosion that vanishes all the traces of the earlier terrestrial history. But on Mars, you have, so to say, a picture of our solar system that goes back to 4.2 billion years, so almost short after the formation of the planets. So if you study Mars, you can learn about the history of the Earth, about the history of the entire solar system, of all the terrestrial planets. You can analyze extremely old rocks, and you can learn a lot with what we call planetary analogy, vergleichen, the comparative planetary exploration. And this is a really neat thing.
They've said no audio, but maybe keep going. Sorry.
I'm almost done. I can add, as a geologist, the other advantages of Mars. It's pretty easy relatively easy to reach compared to other planets. Try to fly to Mercury and you will understand what I mean. But the geologic processes that occurred on Mars are relatively similar to those that occur on Earth. So we have tectonism, we have volcanism, we have the action of wind, we have the action of water. We had the action of water on Mars, actually, but we can see when this water has been there, how much water has been there. We can deduce old climatic conditions 3.7 billion years ago and see whether Mars might have been habitable in this time. And the interesting thing is that we found out that Mars was indeed habitable at 3.6 billion years ago at certain places. And this is exactly the same time when life, the first microbial life, occurred on Earth. And isn't that a question? Isn't that interesting? And now we move on and answering this question, if this is related to each other or not.
Well, Daniela was responding as a geologist, and I would like to respond a bit as a climatologist. In the sense, I am really excited about studying Mars. I grew up as a kid who dreamed of the space, and being right now here is like a dream, like a life dream for me. But as a climatologist, I think that studying Mars and studying the atmospheres of other planets are also a very good way to learn about our own planet. I think that in a way, it's like we can see ourselves in a mirror, and that way you can learn about ourselves. But when we talk to other people and when we learn about other people, we understand better or in a different way ourselves. And I think that with Mars and the other planets, it's kind of the same. When we study other planets, we can understand more about our planet. But also I have to say that we need to be realistic, and we need also to remember that we are now in a huge crisis, in a climate crisis, and we need to do much more than we are doing. In fact, when we look to the Earth from space, we usually think a lot on how beautiful is our planet. There is this pale blue dot image that was taken by the Voyager spacecraft, and I would like to say, save the pale blue dot. This is one of the things that we could say when we look back to the Earth from space. Because saving the pale blue dot, saving the core of the Earth, is not really saving the Earth. The Earth is really resistant. It's about saving ourselves, and this is what we need to think. We need to really act more for this, and this is what I can say as a climatologist.
I just wanted to say that we've got about 7 minutes left now, and Mars is gradually disappearing off of the screen, as people will be noticing. And a few people have asked kind of where it's going and why it's disappearing. So I think it's maybe worth touching on that, just so to get back to what's being shown, and then carry on again with this conversation, which is so interesting. But yes, Mars is gradually disappearing off screen. Why, and can we see it again?
It's disappearing off screen simply because Mars Express is moving past it. So it's currently heading effectively, as we said earlier on, behind it. You can see the elliptical orbit that we're in, and it's as a result of this, it's moving out of the field of view of the camera. We will see it again because it would, if we were to keep this live stream going for another 7 or 8 hours, it would come back round again. Mm-hmm. So we just had a question in terms of whether it's possible to recover the images that were not shown due to bad weather. In principle, yes. It is something that we do have to do from time to time because, as I said, we do have data outages due to weather or issues with the spacecraft or issues with the ground segment. And it's typically involved with, if it was just a problem with getting the data actually to the Mission Control Center here in Darmstadt, and it was actually received at the ground station, then actually it would be quite easy because we can actually connect. It's all recorded at the ground station, and we can simply re-request it. To actually get the data back from the spacecraft, we'll have to send a series of commands to it to tell it to copy the data that it's recorded to a different part of its onboard memory, and then we could redump that later. And are you going to? That would depend a little bit because we've actually to do this live stream, and because actually the data downlink on Mars Express is often extremely sought after by the instrument team. So they're producing science and they want their data down on Earth, and so we have to very carefully schedule all of the data dumps to make sure that we get everything down and nothing's left on board, because at the end of the day, if we can't get it back to Earth, there's no point recording it. And so actually for this live stream to work, we've actually had to turn off an hour's worth of data dumps, including some from HRSC. I'm sorry, Daniela. But rest assured, our mission planning team are actually working in the other room at the moment, because they were actually putting commands up that will go up next week that will actually then dump the data that would have come down in this pass were we not doing the stream.
So in case you missed the introduction earlier, we are talking to you live from the European Space Operations Center, and this is the control room. This is where they send control commands to the spacecraft and where they receive the data coming back to it. There have been some questions about the graphic on the right-hand side, people asking about whether there's an ocean on Mars. So the colors on that simply represent the elevation. So red areas are high, blue areas are low. You might immediately see that the northern hemisphere has lots of low terrains. If there was once a large ocean on Mars, then people think this would have been a sort of sea-covered ocean. There's also a massive impact crater in the south called the Hellas Basin. We think this may have formed when a late bombardment, a late object came and smashed and made a giant impact crater. So it's quite dramatic topography. If you look closely, you can also see some high points, which are very tall volcanoes, the tallest volcanoes in the solar system. About why the image is disappearing. Again, it is an orbit, so we go round and round and round. We go round every just under 8 hours is the orbital period, and so that means that after 7 hours we will be back. By now, Mars Express has completed 24,000 orbits of Mars, so we do have confidence that it will come around again. Because it's done so many times, and not only do our equations say this, but our experience says this as well. So just again a reminder, why are we here today? Why are we doing this? So we are celebrating the 20th anniversary of the launch of Mars Express, which was at 7:45 p.m. Central European time, which is coming up in about an hour or so. But 20 years ago, and the mission was originally built and financed for a mission lifetime at Mars of 1 Mars year. It has now achieved 10 Mars years at Mars. It has now outlived its expected lifetime by a factor of 10, which is just a remarkable testament to everyone who built the mission, who designed the mission, and has operated it. And as one of the scientists who had an instrument which went up originally, this is just amazing to see, and it's wonderful to be here today. Over to you, Rosa.
Yeah, we just have 1 minute left and Mars is disappearing. But if you want to see more images like this, we actually have a less live, but still liver than most images of Mars. And that's if you go to the Mars webcam on social media. It used to be on Twitter. You can still follow at ESA Mars webcam on Twitter, but it's not updating anymore. So we have moved to Mastodon. If anyone is modern, they can go to ESA Mars webcam at mastodon.social, and the images that are currently coming down will actually go straight to Mastodon, not quite as quickly, because what we're doing now is difficult and special, and the team have spent ages preparing for this. So big thank you to them and to everyone that works on Mars Express and all the scientists. You can also go to Flickr. Slightly less modern than Mastodon, but still cool. You can get images on Flickr from Mars Express, and you can go to our website, as always, esa.int, and more news from Mission Control at ESA Operations on Twitter. We're all over the place. And our hour is up and Mars is disappearing. And thanks to everyone, to Daniela, Jorge, Colin, and Simon. And also you can have a look at the incredible HRSC mosaic image of Mars that also came out for the 20th birthday of Mars Express. And thanks to everyone who joined. We've been amazed at how many people have been watching, and it's been very special. It's really rare to get something like this so live. So thank you, everyone.
Yeah. I'll
It was
resist the
fun,
temptation
thank you.
to sing happy birthday tomorrow. But you can all sing it yourselves at home.
Sing happy
Every day since November 1998, the International Space Station has been orbiting the Earth at a speed of 28,000 kilometers per hour. Having spent several months on board the International Space Station, the time has come for 3 of its crew members to travel back to Earth. The return journey aboard a Soyuz capsule takes 3.5 hours. Before it can start, there's a lot of preparation to do, both in space and on the ground. The normal landing site for the Soyuz is Kazakhstan. A group of ground-based experts prepare meticulously for this operation. They take into account the current orbit of the station and then select the most appropriate landing site on the ground. The landing site is checked by the search and rescue team to make sure that the terrain is flat and free from any obstructions that could complicate the landing. The search and rescue team is able to operate even in extreme weather conditions. When all the information has been analyzed, the optimal return trajectory is calculated. One week before the Soyuz undocks from the station, the instructors and controllers located in the Mission Control Center near Moscow conduct a remote training session with the crew and the onboard simulator. During this session, the crew are reminded about the most important actions they will have to perform during the re-entry. They carefully run through the procedures for each critical step, including the scenarios that could lead to an emergency descent. They are also briefed on the latest details of their trip back, such as landing conditions and the precise timelines for the activation of vehicle systems. The onboard crew runs a test of the Soyuz vehicle and begins packing items that will travel with them back to the ground. The Soyuz is then activated, and the crew starts preparing it for undocking. When instructed by the ground controllers, the crew say their goodbyes to the colleagues staying behind and close the hatch that separates the Soyuz orbital module from the station. The hatch is carefully checked to make sure there are no leaks that could cause an unexpected cabin depressurization. The crew members put on their spacesuits and enter the descent module that they will occupy for the ultimate roller coaster ride back to Earth. Former astronaut Frank de Winne is now head of the European Astronaut Center in Cologne. He remembers clearly the emotions he felt as he was about to leave the International Space Station.
Wow, today I'm really going home. Because of course, the days before, you're preparing for the descent, you're reviewing all the procedures, you're going through all the radiograms, but it's only at the moment that you're in your spacesuit and that the hatches are closing that you know that 4 hours later you will be back on Earth.
Both crew and vehicle are now ready for the undocking sequence. The Russian segments of the station have several docking ports for hosting Soyuz vehicles. In this example, the vehicle is going to undock from the so-called service module. In this case, the undocked Soyuz reaches an orbit below the station. The orbital velocity of the Soyuz also increases. Sometimes, however, the Soyuz is docked to a port underneath the station. In these situations, approximately 40 minutes before the undocking, the station changes its orientation. The Soyuz then undocks and joins a higher orbit, and its velocity decreases. In both cases, after one revolution of the Earth, the orbits intersect, but because of their now different velocities, the station and the Soyuz arrive at the intersection point at different times. This prevents any possibility of a collision between the two vehicles. When the flight director is ready, a go is given to the crew to initiate the undocking. The crew commander issues the command to open the Soyuz hooks. These are the only mechanical devices holding the vehicles together. After approximately 3 to 4 minutes, the hooks are fully opened and the Soyuz is no longer firmly attached to the station. A set of pushers that were kept mechanically compressed while docked gently ease the Soyuz away from the station at a relative speed of 12 to 15 centimeters per second.
Undocking confirmed at 9:56 p.m. Central Time.
Being so close to the station, the Soyuz propulsion system is inhibited in order to avoid contamination of the station with residual chemical dust produced by the Soyuz thrusters. The crew gets visual confirmation of the separation through the image provided by the external TV camera and also from indications displayed on their monitors. ESA astronaut Paolo Nespoli returned to Earth aboard a Soyuz spacecraft at the end of Expedition 27.
I didn't actually felt when we detach from the station. Physically, I didn't feel it. The physical departure of the station is done because of a push or some spring that there is inside. You don't want to start your engines close to station because you're going to plume everything. So you're just kind of drifting away, and what you're doing there, what we were doing, we're just looking at the instruments, looking at the camera outside and checking that the Soyuz would be inside the departure corridor. This is what we were doing. Didn't really felt anything. The only thing is that we felt we started this long journey back to Earth.
3 minutes later, when the spacecraft has moved about 20 meters, the crew monitors the 15-second burn that increases the separation speed up to 2 kilometers per hour. This leads the Soyuz to a safe position relative to the space station. After the undocking, the ground controllers upload the data needed by the onboard computer to autonomously perform the descent. The crew is in constant communication with the ground. They verify the validity of the data before allowing the computer to use it. At this stage, the crew must pay special attention to prepare for the next critical operation, the deorbit burn. As can be seen, although the Soyuz is now far away from the station, it is still orbiting the Earth at an altitude close to that of the ISS. The purpose of the deorbit burn is to force the Soyuz to decrease its speed. As a result, the trajectory of the vehicle changes and it re-enters the atmosphere. The atmosphere acts as a natural brake and does most of the work in slowing the Soyuz down until a set of parachutes opens and ensures a relatively soft landing. This braking is achieved by using the main engine located in the rear side of the spacecraft to push against the direction of travel. The required orientation and duration of the braking impulse must be precisely calculated and achieved because it directly influences the steepness of the re-entry path.
If we don't burn enough, then we have still too much speed and we will still be too high in the atmosphere, and we can actually skip off the atmosphere and then go further into space. And that, of course, would not be a successful re-entry. On the other hand, if we burn too much and we come in too steep, then we will have too much speed when we are in the lower parts of the atmosphere. The heat that is normally around 2000 degrees Celsius will be much higher and we have a risk of burning up. So also therefore it's very critical that we do the correct deorbit burn and that we really fix this around 120 meters per second.
To achieve the correct burn, the main engine fires for exactly 4 minutes and 45 seconds. The Soyuz now follows a trajectory that will lead it to intercept the dense layers of the atmosphere, leading to a safe re-entry and landing about 55 minutes later. As the vehicle travels along its trajectory, about 30 minutes before landing, and at an altitude of roughly 140 kilometers, it separates into 3 parts: the orbital module, the descent module, and the instrument compartment. There is no chance of the individual modules colliding with each other. This is called impactless separation. Only the descent module hosting the crew will make it back safely to Earth. The other 2 will disintegrate and burn up in the atmosphere.
The separation of the spacecraft in the 3 parts is happening through several seconds because there are several parts that gets detached after one or the other. All of these actions are done with explosive bolts or explosive implements. seen from inside of the spacecraft, it felt like there was somebody outside the spacecraft with a sledgehammer that was hammering here and there, up and down. And so every few milliseconds, the spacecraft was shaking with this bang, 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 bang. It felt really interesting, actually.
The descent module experiences extreme high temperatures during re-entry, so to protect it and the crew inside, it's fitted with a special protective coating and has a heat shield on its base. As the atmosphere becomes more dense, the descent module positions itself so that its heat shield points forward. The capsule is about to enter the Earth's atmosphere. This will be the most stressful part of its journey home.
By the time we were supposed to re-enter the atmosphere, I actually looked out from our window, and I actually looked, we were tumbling. And I was a little bit puzzled because I thought we need to re-enter in a special angle. So I started looking at procedure, we did a few things, and when I looked out again, I saw that we were already inside this plasma things. It was getting really red, and actually the window was getting pretty dark. What was happening that the plasma stream is actually burning the outside layer of the window, which has a protective cover. So it was kind of interesting. At that point, I really did not feel that much. I mean, the gravity starts grabbing you, but it's very gentle at the beginning, and you actually use it to feel or go into the seat and buckle up, pull your straps so that you really lay into the seat. It was an interesting feeling.
The descent module follows a path that is similar in shape to that made by a surfer riding a big wave. Like a surfer, the Soyuz is able to make small adjustments to keep itself on track. So how is the trajectory of a free-falling capsule controlled? Even though it doesn't have wings, the Soyuz capsule is able to change the way it flies through the air. The design of the Soyuz enables it to do this. The capsule's lift increases when it rotates in one direction and decreases if it rotates in the opposite direction. In this way, the capsule is able to keep to its planned trajectory. As a side effect, this rotation also induces a sideways displacement of the module. This effect is very useful because it gives more flexibility for the selection of the landing site. This sideways maneuver has already been taken into account when selecting the optimum trajectory. During the descent in the atmosphere, the crew feels the effect of the deceleration when their weight exceeds several times their own weight on the ground. The maximum G-load, 4G, is experienced when the capsule reaches an altitude of roughly 35 kilometers, when it's already been traveling for 6 to 7 minutes in the atmosphere.
Gravity is a very, very strong force. We do not understand here on Earth how gravity has such a hold on our body, on what is around us. You do feel it when you come back from space, because now you have been in a non-gravity environment for a long time, and then you see all these forces grabbing you. You look at stuff and you feel your hands are heavy, you feel your watch weighs a ton, your books, the materials around you, your head, it's extremely heavy. And it's really, really, really a very strong feeling.
In the unlikely event that the automatic control system fails, the crew is able to use a manual hand controller as a backup. They train extensively to prepare for this possibility. Another option is the ballistic descent. The spacecraft starts spinning and flies a much steeper trajectory without any additional sideways displacement. The G-load in this case will increase up to 9. When the capsule reaches an altitude of 10.5 kilometers, its speed has already decreased from 28,000 to 800 kilometers an hour. In order to further decrease the speed, the parachute cover is jettisoned and a series of parachutes are deployed.
At the end of the atmospheric re-entry, you really start hearing the noise of the wind and the sound. You're almost breaking the sound barrier. Then in the opposite direction, of course, you're coming back into the normal area of flying. And And this is around 30,000 feet that the parachute has to open. This is actually a very critical moment, and it's one of the only things in the Soyuz where the crew does not have a manual override. So this is only an automated system. So far it has always worked, and we also have a backup parachute that can help us in case that the main would not open. But it's also a very violent moment. You can imagine this 2,000 kilogram capsule that is soaring at the speed of sound through the atmosphere. And then all of a sudden you have a parachute that opens on the side and that pulls on you like with a little string. It's almost like a yo-yo, and you see the capsule going all around. It's much worse than in a roller coaster because it motions in all directions. And it's a little bit scary for some of us. For some others, it can also be fun to say like, oh, this is the best ride I ever had.
Then, a few minutes later, at a height of 8.5 kilometers, the drogue chute finally deploys the 1,000 square meter canopy of the main parachute. This slows the capsule down to a speed of 22 kilometers per hour. The capsule is suspended under the parachute with a specific angle relative to the ground. This angle helps the capsule to dissipate the heat accumulated on its surface and structure during the re-entry.
But then everything calms down, of course, once that the main parachute has deployed. You really can't to the calm air after this whole violent re-entry, the violent opening of the parachute. Then you're hanging safely, slowly descending to the earth underneath your parachute. And this is actually the first time that you know, yes, I'm safe, we're gonna make it.
At an altitude of roughly 5.5 kilometers, the frontal heat shield and external window glass are jettisoned. The capsule vents excess fuel and oxygen from pressurized tanks to reduce any chance of an explosion when it hits the ground. In order to position the spacecraft adequately for the landing, the main canopy switches to symmetric suspension. This setup ensures that cosmonauts' seats are now perfectly positioned to absorb the landing impact shock. The retro rockets that were hidden behind the heat shield are prepared for firing. Inside the capsule, the crew seats automatically raise in order to prepare shock absorbers. Usually, the search and rescue team equipped with aircraft and helicopters start tracking the Soyuz capsule even before the very first parachute is deployed. The helicopters land next to the capsule shortly after touchdown, and the team help the crew to exit. Finally, 70 centimeters above the ground, the 6 retro rockets fire to further reduce the capsule speed to approximately 5 kilometers per hour. The capsule hits the ground, but the crew's seats continue moving down, and shock absorbers help to make the landing softer for the crew.
The soft landing is not really soft. You prepare for it by putting your arms against your body, not touching any of the metallic parts, all your books against you. You're not talking, not to put the tongue in the middle of your teeth, and you're laying there trying to be as inside your seat as well as you can. And you're waiting for this soft landing to happen, which for me, it felt like a head-on collision between a truck and a small car, and of course, I was in the small car. So when this happened, it was like, bada boom! Everything shook. I was kind of checking in there. Everything was saying, and then silence. Everything was stopped. So I looked a little bit around. I looked at my crew members, and then I said, "Hey guys, welcome back to Earth."
Once landed, one of the first actions of the crew commander is to release one of the 2 ropes that connect the capsule to the parachute. This is important, as in windy conditions, it prevents the capsule from being dragged away on the ground by the inflated parachute.
You know that you're on the ground, you hear the voices of the rescue troops that are next to you, and you know that 5 minutes later they will open up the hatch and you can breathe fresh air.
The crew is now safely back on Earth. They will soon be reunited with their families and begin the rehabilitation process after their extraordinary journey.
270 meters and closing. Crew Dragon expected to converge with waypoint 1 directly in front of the International Space Station in less than 5 minutes. You can see the views right over the shoulders of Commander Shane Kimbrough and pilot Megan MacArthur. Kimbrough on the left, MacArthur on the right from that view.
From this view from the International Space Station, you can see what we were mentioning earlier, where Dragon was below the station. You could see that previously when it had Earth in the background. Now it is almost adjacent, or almost in the same orbit as the International Space Station, as it's making its way to the docking axis at waypoint 1. Now this maneuver from below the station to in front of the docking port is almost complete, just a few minutes away.
Getting great views from all around, from the station side, from the Dragon side. The outline of the station you see on the displays inside Crew Dragon is in line with the position of where Dragon is relative to the International Space Station. It's almost at the docking axis, about 2.5 minutes to go until it converges with waypoint 1.
And as a reminder, Dragon is flying autonomously, so they aren't using those display panels to fly Dragon. They're just using them to monitor each step of the way. So the crew is basically just patiently waiting until they dock with the station.
Now seeing Dragon in a better view, a lot more clear now that it's only 240 meters away. You can see the nose cone clearly deployed, extended towards the space-facing side or zenith side.
A really good zoomed-in view, and you could almost make out those 4 bulkhead thrusters on the forward portion of the Dragon capsule.
There you go. The Cronus is adjusting the aperture of the station cameras.
Dragon SpaceX on the big loop. Approach 1 and soft capture ring extension will begin shortly. Dragon will continue to waypoint 2, with the additional lighting assessment occurring at 110 meters, as previously noted. For awareness, if sunlight results in the loss of the Dragonite geofilters, Dragon will autonomously retreat back to waypoint 1, remaining on closed loop control using the time of flight filters. I'll copy.
We are in a handover period, so we may have missed a call as we were switching from TDRS satellites. We're looking at about 20 seconds to go until we converge with waypoint 1. There's going to be an approach burn maneuver using the Draco thrusters. That's called approach 1, and that'll move Dragon from right in front of the docking axis, 220 meters away, and start moving in, closing in to waypoint 2, just 20 meters away from the docking axis. Of course, they'll be monitoring along the way.
We did hear the Corps mention that they are going to have a checkpoint to make sure that there isn't too much sunlight on the space station, which will prevent Dragon from docking. If that does happen, Dragon will autonomously back out and wait until the sunlight has cleared to ensure a good docking with the space station. Because this is all autonomous, it uses some visual cameras to align with the docking port. So it's really important that we don't have that sunlight getting in the way.
Section Dover on the big loop, sound check.
SpaceX has you loud and clear on the big loop. Helm me.
Loud and clear. Your last call, we copied most of it, but you cut out towards the end there. I'm not sure if there's anything important for us.
Copy. I'm going to repeat the end of the call. We did have a TDRS handover. Just for awareness, following the lighting assessment, if we continue but sunlight results in a loss of the Dragon Eye geofilters, Dragon Eye will autonomously retreat back to waypoint 1, still on closed loop control using the time of flight filters. How copy?
Okay, we copied all. Thank you very much for repeating.
No problem, Shane. And for awareness, the C2V2 link reconfiguration has been completed.
Copy, C2V2 complete.
And there, the Corps just reiterated that they will be checking to make sure that the sunlight is not in the way of the visual systems between Dragon and the space station. If that does happen, Dragon will autonomously retract and wait until we do get some good visual views for these systems to dock with each other. So
that's right. Crew Dragon resilience actually coming into view a little bit clearer now from the cameras aboard Dragon. Dock to the zenith port.
Yeah, that was on the upper portion of the screen.
That's right. Now again, to reiterate, Dragon has passed waypoint 1, 220 meters in front of the station, executed a burn maneuver to go ahead and move in. So we're in approach 1, and it's heading towards waypoint 2. Now inside the keep-out sphere. It's currently in the process of extending its soft capture ring that'll be used to dock to the international docking adapter of the forward port. We're monitoring the visual systems of Dragon. It would execute an automatic retreat if the sun was interfering with the optical systems as it makes its way towards an approach. We're at about 150 meters away from the station.
And we have such a great camera view here. You can really see the detail on Dragon. Again, those 4 bulkhead thrusters. You could almost read the logo, the Dragon logo on the side of the vehicle.
That's right. We'll get even better views as it makes its way even closer to make contact and capture with the space station.
There it is.
Yeah, based on the trajectory here, we may even anticipate a capture a little bit earlier than anticipating. We were looking at about 2:10 a.m. Pacific time. It might be at maybe closer to 2:07 p.m. features of the space station coming into view very clearly.
Yeah, you can see a lot of the detail there, and as you mentioned, the Crew 1 Dragon.
SpaceX station on the big loop. Procedure review complete, ready for docking.
Houston copies.
All right, that was confirmation from Victor Glover aboard the International Space Station. From the space station side, he is go for docking. The soft capture ring itself is fully extended. We're 115 meters in closing.
Looking at your screen, the port that we are going to be docking with is directly in the middle of the screen, that circular area on the International Space Station.
Station Houston on 2 for Ike regarding SSC 17 and D2DM. We are seeing some strange configurations on the video, and we would like to close and restart that. We can take care of that from the ground if you would like. Absolutely. If you're seeing nominal, that works for us.
Okay, so Victor Glover aboard the station still has...
And Dragon SpaceX soft capture ring extension is complete. Additionally, we did beat the sunlight for the Dragon Eye filters, so we are not going to command a hold.
Copies off.
All right, so that's great news. We passed the 110-meter checkpoint that the ground operators were referencing, making sure the sun wasn't interfering with the optical sensors, the Dragon Eye, that are part of the guidance and navigation and control system aboard Dragon. We passed that check mark. We're good to go. We beat the sun there. So we're now inside 80 meters and closing. Dragon will pause at 20 meters. That's designated as waypoint 2 to conduct a go, no-go poll for the readiness on both the Dragon side and the International Space Station side, making sure everyone is good for docking. If we are go, we expect to dock during this pass over an orbital daytime. Expected in less than 20 minutes. Some of the features there, you can see a lot of the visiting vehicles on board station. At the bottom is a Russian Soyuz vehicle that delivered crew to the International Space Station. Just in front of that, or actually above that, is the Crew Dragon Resilience docked to the Zenith port. Once Crew Dragon Endeavour arrives, there will be 2 Crew Dragons attached to the space station.
And this view from Crew Dragon looking at the International Space Station, it looks like it's this very slow and steady movement, but in reality they're moving at 17,500 miles per hour.
The rendezvous operations are absolutely incredible. You can sort of see the Northrop Grumman Cygnus cargo craft as well, some of the ultraflex solar arrays coming into view a little bit clearly.
And you could see that Crew 1 Dragon vehicle on the top of your screen. Once Crew 2 docks to the International Space Station, we will have 2 Crew Dragons docked at the same time for the first time.
That view right there was truly a representation truly of an international cooperation there. The U.S.-built Node 2 is where the Dragon will be docking today. It was flanked by the European Columbus module and the Japanese GEM.
On the big loop, visors down.
SpaceX copies. The visors are down. We may enter into a hold at waypoint 2. We are still awaiting ground go for final approach.
Never copies.
The detail of this camera view is pretty incredible. Here from the International Space Station, watching Crew Dragon as it is slowly approaching.
And as expected, Dragon holding at waypoint 2. It's at about 20 meters right in front of the docking axis.
And if you're just now joining us, we are just waiting for a confirmation for go for docking. Currently holding Dragon at waypoint 2. And again, it looks like Dragon is just paused and not even moving, but again, as we just mentioned, both the space station and Crew Dragon are actually moving at approximately 17,500 miles per hour. So it's pretty incredible how it can hold these speeds so that it looks like they are just completely paused.
That's right. Teams on the ground, both from the station side in Mission Control Houston and Mission Control Hawthorne, just checking and verifying all systems are go to proceed with docking.
And when we do begin docking, there will be 2 portions of this. There will be a soft capture followed by a hard capture. The soft capture will be a soft capture ring that basically just connects the Crew Dragon to the space station to enable the hard capture, which will be 12 hooks that will attach Dragon to the station.
Again, we're standing by the International Space Station, flying over the Indian Ocean now, just south of the Indian border. It's heading on a southeasterly course just south of Australia and should cross over the Terminator line into the Pacific Ocean into an orbital nighttime. The expectation is for Dragon to depart here from waypoint 2 and proceed on with docking ahead of orbital nighttime to beat the sun.
can see this camera moving around. Again, this is controlled from the ground from Mission Control Houston. And they're maneuvering this camera around so we can just get a more detailed view of the Crew 2 Dragon Endeavour patiently waiting, docking to the International Space Station.
Dragon on its second flight, about to dock to the forward end of the International Space Station for the second time.
And Station and Endeavour on the big loop. Ike, we are not able to recover that video for the D2DM, so you can close that window, and we should be ready to press into final approach shortly.
Station copies.
You did hear that call out speak out to Ike. Ike is actually referring to Victor Glover. That is just his nickname.
Dragon SpaceX on the big loop. Ground is now go for final approach. Upon confirmation of crew readiness for final approach, we will enable the approach. Please confirm crew readiness, and a reminder, once Dragon is inside the crew hands-off point, retreat and breakout are no longer permitted.
Crew is ready for final approach.
And got some good words that the crew is ready for the docking to the International Space Station. They no longer will have control of any aborts. If there is an abort needed, it will have to be done by the Dragon autonomously.
And on the big loop, monitor per steps 3 and 4 and 1.104.
Station copy.
Again, we are now moving into the CHOP, which is the crew hands-off point. As I was mentioning earlier, if there is an abort, it will need to be done autonomously by Dragon.
All right, we did get confirmation. Approach 2 has been initiated. So Dragon now making its way inside the 20-meter hold point at about 18 meters and closing. Final approach of Endeavour to dock with the International Space Station has started. Docking expected in about 3.5 minutes from now.
You can see on your screen as Crew Dragon slowly approaches towards that port for docking.
Sorry, we're 13 meters and closing, making a slow and methodical approach to the docking port. That's on the forward end of the International Space Station, that international docking adapter where Crew Dragon Endeavour has docked once before.
Meters.
Copy, 10 meters.
That call out was Crew Dragon is just 10 meters away from the International Space Station as it continues its approach for docking. Again, docking will occur in two phases. There will be a soft capture followed by a hard capture, and what that hard capture means is 12 physical hooks will connect the Dragon to the space station.
Great views. Dragon just 6 meters away as the station and Dragon fly in tandem 263 statute miles over the South Indian Ocean in the background.
5 meters.
We're 5 meters and closing.
Copy 5 meters.
Really start to see the detail on Dragon there as it is closing in on docking.
That's right, 2.5 meters, 30 seconds. Crew hands off point was called out.
Dragon SpaceX on the big loop, soft capture confirmed.
Copy, soft capture confirmed.
Great news with that call out. That soft capture is confirmed.
That's right, that soft capture time, 2:08 a.m. Pacific time, 4:08 a.m. Eastern. The station and Dragon connected 264 statute miles over the South Indian Ocean. Endeavour connected to International Space Station for the second time.
And there are still a few steps to complete before Dragon is securely attached.
Dragon SpaceX on the big loop, soft capture ring retraction in progress.
That's good. The ring retraction is happening. Ring retraction happening as expected. And after the ring retracts, 12 hooks will latch, 6 at a time, to perform a hard capture, and will officially mate Dragon to the International Space Station.
Got this really awesome view of Dragon as it is connected to the port, currently making progress on hard capture.
Soft capture ring retraction does take some time. It is continuing at its anticipated speed. Things are looking good. Again, this is the first in a series of steps to officially mate Dragon to the station. If you're just joining us, we heard the call out for soft capture confirmed at 2:08 a.m. Pacific time, 4:08 a.m. Eastern time. Station and Dragon were 264 statute miles over the South Indian Ocean at the time of contact and capture. We're still in the process of retracting the soft capture ring and anticipating proceeding with the hard capture sequence, where 12 hooks will drive to officially mate Dragon with the International Space Station's International Docking Adapter at the forward port. Crew Dragon Endeavour docked to that forward port for the second time.
Dragon SpaceX on the big loop. Ring retraction is complete. Docking sequence is holding for MCS reconfiguration.
Endeavour copies all. If you're just now joining us, as you can see on your screen, Crew Dragon has made contact with the International Space Station. And we're currently in progress of...
Endeavour and station. MCS is configured. Proceeding with hook driving.
Endeavour copies. Station copies.
Great timing there. This is now the beginning of the hard capture sequence. This is where 12 hooks will latch between Dragon and the space station, 6 hooks at a time. This will take a few minutes to complete.
That's right, that MCS is just configuring the International Space Station's attitude control. It needed to be configured differently between a soft capture and hard capture sequence. So now that that's been confirmed, they can go ahead and press to drive the 12 hooks needed to confirm a hard capture. To reiterate, the Dragon had contact and capture with the space station at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. Space Station and Dragon crossing over the Terminator line, just south of Australia, about to head over the South Pacific Ocean. Start seeing the views of Dragon get a little bit dimmer as we still undergo the hard capture sequence. All right, again, we're still undergoing the hard capture sequence. There's 12 hooks that drive to officially mate Dragon to the International Space Station, 6 of them driving currently. Station attitude configured to support the hard capture sequence, now operating on control moment gyros to maintain attitude control during the hard capture sequence. All right, and we have confirmation the first set of hooks, all 6 have been driven. They look good. The second set are driving and are looking good at the anticipated speed. Halfway there.
This will take just a couple more minutes for hard capture to complete. As a reminder, after hard capture is complete, they do still have some more steps that they need to go through in order to ensure that the space station and Dragon are safe for crew ingress. There will be the hatch opening as the crew on board Dragon as well as the station will be walking through some procedures prior to ingress of the crew on the International Space Station. But once they do ingress on the station, there will be a welcome ceremony.
Again, half of the hard capture hooks have been driven and locked into place. The second set of 6 hooks, 12 total, 6 of them driving.
Dragon SpaceX on the big loop, hard capture is complete. You are go to open visors.
Copy, hard capture complete, opening visors.
All right, Crew Dragon Endeavour officially made it to the International Space Station. That dynamic period of the docking phase is complete. The crew inside Dragon have been wearing their suits just as an extra precaution, but they can go ahead and pull up their visors. It's going to be some time until the hatches themselves are open between Dragon and the International Space Station. Still some things to configure on that side. The vestibule on the International Docking Adapter that separates the hatches of Dragon and the International Space Station, that's been exposed to the vacuum of space and has had the sun shining on it periodically. So when repressurizing the vestibule to equal the pressure inside the space station.
Station, hard capture complete. Welcome to ISS. We are so excited to have you aboard.
Thanks, Anna. We're glad to be here. We'll see you all in a few minutes.
International Space Station Commander Shannon Walker welcoming the crew. Now Crew 2 officially made it to the International Space Station. Again, it's going to be some time until they come in, but the commander of the International Space Station welcoming 4 new crew members for her expedition on board here shortly. All right, so again, there's a series of steps here as we enter into an orbital nighttime, completing the docking of Crew Dragon Endeavour to the International Space Station for a second time. That contact and capture occurring at 2:08 a.m. Pacific time, 5:08 a.m. Eastern. We have a confirmed hard capture. The umbilical is in motion to connect the station to the Dragon and provide data and power and communication through that umbilical, so it no longer has to rely on its own systems. Everything's looking good for that vehicle. It's going to be some time again until we repressurize the vestibule and get those hatches open between the Dragon and the International Space Station. It'll be the crew inside the station getting that ready to be opened.
Endeavour SpaceX docking sequence is complete. Welcome to the ISS.
Thank you, SpaceX. Great to be here.
In some more official words, that docking is complete. The crew must be so excited to finally have arrived at the space station. Again, there is some more steps that they will need to complete and some checks before they can ingress on the space station. But the crew can now get out of their suits before moving into hatch operations. So now they can start to get comfortable again. They no longer need these suits now that they have arrived at the space station.
That's right. And so it'll be some time again until that area between the International Space Station and or the hatches.
SpaceX Endeavour on Dragon to ground. Are you ready for us to begin seat doffing?
SpaceX copies. You are go to begin suit doffing and audio configuration. Procedure 4.012.
Copy, that's in work.
So again, it'll take some time. The crew will begin doffing or taking off their suits. It'll be some time to repressurize the vestibule. Station side, astronauts on the station side will configure the hatch, getting ready to open that up and welcome the crew inside the International Space Station. It was a pretty great docking. Everything happened right on cue and as expected. So it was a great to see Crew Dragon Endeavour dock to the International Space Station once again. We've enjoyed it from here in Mission Control Hawthorne, but to see how things turned out from the space station side of things as we work together to complete today's operation, let's go to Courtney Beasley for a refresher on what's ahead now that Dragon is docked.
Cameras are external.
Copy, thanks.
Thanks, Gary. It's great to see Dragon successfully docked to the International Space Station. Even through the face masks, you can see and feel the excitement in the room here in Mission Control Houston. Now that we're docked, Victor Glover is securing some hardware, and then he'll move right into hatch operations. First, he will open the large hatch at Node 2 forward, giving him access inside the pressurized mating adapter. Then he will have to pressurize the vestibule, which is the small space between the hatches on Dragon and the space station. This was exposed to vacuum prior to docking, and he will need to fill it with air and make sure its pressure is nearly equal with the atmospheric pressures on Dragon and the station. He will use a small valve on the station's hatch to slowly introduce air into the vestibule, and flight controllers here in Houston will monitor the pressure and temperature readings inside and verify that everything is leak-free before we get ready to open up the hatches. We expect it to take about 2 hours to get everything pressurized and checked out before we open hatches. With Dragon successfully docked to the International Space Station, that's the latest from here in Mission Control Houston. And back to the team over in Hawthorne.
All right, thanks, Courtney. As mentioned, it will take some time to go ahead and go through those procedures, but we'll stay with you throughout today's coverage. Of course, one of the major things will be repressurizing the vestibule in between the hatches. There's a hatch called the APAS hatch. That's the hatch on the International Space Station side. And then there's the Dragon hatch itself. In between is a vestibule that's currently at vacuum. So in order to travel through both hatches, you need to repressurize that. Now that there's a hard mate between the two vehicles, they'll check the seal. They'll do some leak checks as they're repressurizing the vestibule up to vacuum. And that will take some time.
SpaceX Endeavour, check on the cabin mic.
SpaceX has you loud and clear on the cabin mic.
We have you the same, thanks.
You're hearing the crew inside Endeavour go through their procedures. One of the first things they're ready to do is take off those suits. They had to wear it through several of the operations of a launch from the Kennedy Space Center to a docking with the International Space Station. Launch is a very dynamic activity, so they had suits on up until orbital insertion, and then they were able to doff their suits, have a meal, go to bed, check out some of the systems, wake up, and then right before they entered into the approach phase of today's flight with the approach initiation burn, they got their suits on and were able to pressurize them, and they held pressure throughout that sequence of today's flight until docking. Now they get to take it off. They get to stretch out, change into something a little bit more comfortable, but not too comfortable, of course, because they will be. We will have an event to welcome them on board the International Space Station we expect all 11 crew members to be there to welcome them. It's going to be pretty crowded, but it should be very exciting to see that many people on board the International Space Station.
And those call-outs that we just heard were, they were doing a comm check with the Crew Dragon communications, because they've now taken off their suits. They have comms through their suits, but since they're not going to be wearing their suits anymore, they need to use the comms through Dragon. So very exciting. It sounds like they're getting out of their suits as we speak, or doffing their suits. And then we will soon begin the process to open up those hatches so that the crew can finally ingress onto the space station. So it will take a little bit of time, but we will be here with you through every step of the way. If you're just now joining us, the Crew 2 crew has finally docked to the International Space Station after an approximately 23-hour ride from Earth to the station. Again, they are going to be performing a few procedures here before the Crew 2 can ingress onto the space station. They will be opening the APAS hatch, which is the space station side hatch, followed by the Dragon hatch. But this will take some time. They will need to repressurize the vestibule in between those two hatches before the crew can ingress.
That's right, the umbilical on the Dragon side has been fully extended to provide power, communications, and data from the International Space Station to the Dragon, so the Dragon no longer needing to rely on its own power systems. And of course, when the hatches are open, they'll be able to mix the air from the environment that's inside the space station with the Dragon, so it no longer needs to rely on its environmental control and life support systems. In the meantime, it is still doing so because the hatches are closed between both the Dragon and the International Space Station. There is a gap called the vestibule in between them that's currently at vacuum. That vestibule has been exposed to the vacuum of space on the forward end of the International Docking Adapter. So when bringing the pressure back up, there may be swings. Because of the temperature variation, there may be swings that need to dampen out before an effective leak check could take place. So the process of repressurizing the vestibule in between those two hatches does take quite a long time. It's expected to be about 2 hours until both of the hatches are open because of the length of time of repressuring that vestibule. Now from the station side, Victor Glover will outfit the 8-pass hatch. That's the one on the station side. He'll open it up and remove, once the vestibule is pressurized, he'll open that up and remove the docking target and install some padding onto the 8-pass hatch so that there's no unnecessary contact as astronauts are coming through the hatch from Crew Dragon to come inside of the forward end of the International Space Station.
Station Houston on 2 on the big loop. You are go to pick up in ingress part 1, step 1. Note that the pre-ingress ventilation in step 1.6 is not required.
Okay, picking up step 1 and 1.6 not required.
Dragon SpaceX, no response required, but ISS power connection has been established.
There you go. So Victor Glover on the International Space Station side already going through his procedures to get the hatches configured for ingress, essentially supporting the opening of the hatches, repressurizing in the vestibule. There's a lot to happen before we can open up the hatch and welcome the crew on the inside. The umbilical has been fully extended, and we just got confirmation that Dragon is drawing power from the International Space Station, so the solar arrays on the station providing power downstream to the Dragon. Dragon no longer needing to rely on its power. That officially confirmed. It will again take some time until the Dragon hatches are open. Dragon and Space Station hatches are open. And we've noticed for the past 2 times that Crew Dragons have docked to the station. The past 2 times being when Crew was aboard for Demo 2 and for Crew 1. We did notice that the crew inside Dragon took some time before to get themselves situated, make sure everything on the Dragon side was configured before they left it and entered into the International Space Station. We should see celebratory hugs from the crew on board as they make their way one at a time, as they'll be together for the next few days until they have to say farewell to the Crew 1 astronauts aboard the International Space Station. Shannon Walker handing over command of the International Space Station. Before she does that, she's going to hand command over to Aki Hoshide, who's currently on board Crew 2. He'll take the responsibility of International Space Station commander through the duration of Expedition 65 until he's ready to hand it off to the next crew. That all happening in the next couple of days.
Crew Dragon Endeavour is docked to the International Space Station as we speak. The crew on board the space station as well as Crew 2 are preparing for a couple procedures here for hatch opening. That is the hatch opening on the space station side as well as the Crew Dragon hatch. And this will take approximately an hour, a little over an hour and a half to walk through all of these procedures. So though Crew 2 is at
station on the big loop, no 2 forward hatches open.
And Ike, we copy, and you are go to continue through step 2, pressurizing vestibule.
Continue through step 2.
As I mentioned, they are walking through several procedures to get those 2 hatches open. As you can hear, that communication between Victor Glover on board the station with the ground team helping him out with the procedures.
That first hatch that he mentioned is the Node 2 forward hatch. From inside the Node 2 segment of the International Space Station, there are 3 hatches to get from Node 2 all the way down to the Dragon itself.
Dragon SpaceX, if desired, reference procedure 4.400 for monitoring vestibule pressurization.
Copy 4.400 for vestibule depress.
So now that Node 2 forward hatch is open, Victor Glover inside the pressurized mating adapter. Down the PMA is the A-pass hatch, the hatch that separates the International Space Station now from the Dragon. With the Node 2 forward hatch open, Victor Glover can work to manually pressurize the vestibule. And we just heard from here in Mission Control Hawthorne that the crew on board Dragon Endeavour will be able to monitor the vestibule pressurization on their displays from the side of the Crew Dragon.